Hi guys, happy Monday. All right, as you can tell, I am not here again on another Monday. It's not my intent and I don't plan to miss all these Mondays, but it's funny how it turned out this year in golf team. This is not normal. But nothing about this year has been normal, right? Okay, so I am talking to you guys directly today because I wanted to go over a few things and I thought it was easier than me actually typing these things out because sometimes it's hard to type things out. You kind of lose things in translation. So the first thing I wanted to talk to you guys about are those presentations, the feedback. I will give you guys your feedback in person. Remember the little sheets? I don't have any handy right here. So the little sheets the rubrics that we wrote on, I'm going to give those back to you, okay? I know that I don't have all the scores in. I'm working at getting all of them in, so they'll be in shortly. Remember that when I was scoring your project, I was scoring it directly off of that rubric, which were all the little key requirements that I was looking for the project. So, for example, if you didn't use vocabulary or maybe you used a couple of the words, but you didn't actually explain what they meant, that doesn't actually count as using the vocabulary and defining it, okay? So if you're curious about, well, why is my grade this way, but I don't get my feedback till later this week, you can always look at the rubric and kind of compare it to what you actually did, and should have a pretty good idea of how that worked out. Okay. So I am going to get those back. I've already had a few people ask about, hey, can I redo something to improve my grade? And yeah, you absolutely can. I will introduce that opportunity to you guys on Wednesday during Zoom. That way, again, we have that chance to kind of talk with each other. If you have questions, I can answer your questions. But then again, you're not reading it and it's getting lost in translation. So Wednesday, I will introduce that redo type option for these projects. Okay. I think moving on. Oh, wait, no, I know. My first hour class, I think you were my only class that we did not have time to finish everything. So, you guys did a great job getting those to me. I think I decided, well, I know I did because I couldn't figure out the logistics on how I could make this work for today with me being gone. So, we will play those videos Thursday morning when we all get in here, and that way everyone still sees what you've done and then we can score it right then and there. Okay, so I just wanted to tell you guys that I did get those. Thank you. But I think that's what we'll do is we'll wait till Thursday and we'll take a look at those, and then that part of the presentations will be completed. Okay, so that leads me into what we're actually going to work on today. Today, we're taking what we've been learning about balanced and unbalanced forces, and now we're going to focus a little bit on a little smaller part. We're going to look directly at just net force. Okay, so if you guys remember what net force is the amount of force left over on an unbalanced force. So backing up just a little bit, quick reminder, what is a balanced force? So a great example of a balanced force could be my water bottle right here. I have it placed on the table and it is not moving. So we would say that my water bottle is a balanced force because it's not moving at all. Now, if we were in a car on, let's say, cruise control, going down a highway in a straight pathway, and we are not turning or curving, changing our direction at all, then we would also be considered a balanced force. A net force would be any object that has movement or at the time has changed its position from one place to another, or maybe changed the direction that it's going or changed its speed. So, for example, my pen, let's pretend it's on a shelf. Oh, there we go. And it's on a shelf, and then my hand, as an unbalanced force, applies force to it, and I made it fall. Okay, so then it changed position and it became an unbalanced force. Okay, so the amount of force left over was the force that caused it to actually move. Okay, so we're going to look closely at that net force. Let me see if I can figure this out. And I'm going to recap a few things for us, and we're going to go over what our goals are for this specific unit. Sorry about that. I'm pretty sure you guys can hear the phone ringing. My daughter's in here with me. Okay, so here we go. Our focus here is we're going to learn how to demonstrate how an unbalanced force can change the speed or direction of an object's motion. Okay, so here we're going to have an object that's already in motion, and we're going to do demonstrations. Okay, demonstrations are going to be more that hands-on on how an unbalanced force can change another object's speed or direction. And then we're going to work on how to calculate how an unbalanced force change the speed or direction of an object's motion. Okay, so here again, we're going to do some more calculations. And we touched on that just a tad bit in the last unit. I kind of showed you guys with the arrows and the adding and subtracting, but we're going to do a little bit more of that during this unit. And this is going to be more of kind of a mini unit and everything. So I'm hoping it won't take very long for us to get through this so that we can move on to the next one that's going to be a little bit bigger. Okay, so I wanted to go over a couple of reminders and this anchor chart. So if you see this anchor chart, my anchor chart is very easy to read, not a lot of words on it, just a couple pictures with 2 examples and explanation for each example. So here's what we're looking at right here. You can see 2 people pushing a car in the snow. Well, the force that these people are applying would be added together to create one net force because they're both going in the same direction, okay? So, net force, anytime your forces are going in the same direction, you'll add them up to get a net force. When you have objects that are going in opposite directions, so you can see that as they're pushing, pushing in opposite directions, or the force being applied is going in opposite direction, you would subtract. Okay, so anytime you have opposites, you're going to go in subtraction to get your net force. Okay, so those are the highlights for you to remember for today. This is kind of our little bit of our intro, and I think I'm going to give you guys a couple of examples. We're going to work through a couple problems here really quick so that you can remember some more details about going in equal and opposite direction, or not equal, but going in same directions and opposite directions to remember what to do if you add or subtract. So I'm going to try to set this up so that, I'm not sure if it worked or not. I'm clicking buttons. Oh, nope, that's not the button I want. Let's see. Okay, so this might work. You might still see me, you might not. Again, I'm still working to figure these things out. So let's remember that our net force is the amount of force. That's my F, that's my T, left over. Okay, and that's what net force is. It's just our force left over. The N is our newtons. Okay, that's what it represents, is newtons, and what that is the unit force is measured in. Okay, so if you want to get out a piece of paper and kind of follow along with me, you can. Or if you'd rather just watch, that's totally fine too. Okay, so let's look at our boxes. Sorry, I tried to draw boxes here. So we're going to look at this one. This one's going to be number 1. And I'm going to put, let's see, a force on it this direction for, let's say, 30 newtons. And this one is another force and another 30 newtons. Okay, so the way that we will solve this one, because I'm going to want to know what is the net force. Okay, that's what we're doing here. What is the net force? Okay, so that's what we're solving for. So I'm going to say we have 30 newtons, and because our newtons are going in the same direction, you're going to add them another 30 newtons. So our answer is going to be 60 newtons in this direction. So right there is my answer. So it's very important that when you have a net force, you are identifying, and we're just going to use arrows, but you are identifying the direction the force is going to be moving. Okay, that's really important that you're doing that. Let's do another one. How about, we're going to apply a force this direction, and we're going to say it's 10 newtons. And then we're going to do another one, and let's say this one is 45 newtons. Okay, so what we notice about our arrows is they are going in opposite directions. Okay, so what we do when we are opposite is we are going to subtract. Here, remember we added. So I'm going to write, and I'm going to start with my bigger number first just to keep this easy in my head. 45 newtons minus 10 newtons equals 35 newtons. Okay? So what direction are my newtons going to move? Well, this one is bigger, so my arrow is going to go this direction. And that is my net force, 35 newtons. Technically, the way I'm looking at it, it would be to my left. But I'm just going to represent this in arrows because it makes it very clear and easy to understand, okay? All right, so let's look at another one. This one, I'm going to put arrow going down on this one. And I'm going to say it's got about 25 newtons being applied there. And then in this direction, it's going to be 40 newtons. Okay, so what we noticed is my arrows are going in the same direction, which means that they are going to add together. So I'm going to add 40 plus 20, whoops, I forgot my newtons. Got to have that in, 25 newtons equals, well, when you add those together, you get 65 newtons, and in the direction, well, my arrows are pointing downward. So there is my answer on that one, okay? And let's do one more, see if you guys can get this one. I'm going to do an arrow going this direction for 10 newtons. I'm going to have another, like 2 people pushing, like we saw in the car example. And I'm going to put 20 newtons on this one. But then we have some opposing. So maybe we're playing a little tug of war here. And we're going to say 35 newtons on this one. So because these two are going in the same direction, we are going to add these up, but then overall it's opposite, and we are going to subtract them. So 10 plus 20 is going to be 30 newtons, and then we have opposite, so we're going to subtract it from 35 newtons, which is going to equal 5 newtons as our net force, and this one was bigger, so we're going to take it again, kind of pointing toward the left, and this is how we just solved for that one. Okay, so I think you guys are good, and I'm going to get off here, and you guys are good to start the lab. It'll be the net force lab. It'll be in Canvas. Okay, so remember, always go to the modules. That's where everything is always located. And then it'll be there at the top with week 6. All right? Have a good day, and I will see you guys later this week.